Hello everybody, hello, with a new episode from your favorite artist electronist, Mr. Q12, with a very interesting project, I may add. I have a new folder here, if you can follow the root, info Arduino Uno code samples, Rotary encoder, you can see it here, Rotary encoder, in the Arduino code samples. And this is a new folder, specific, made for my Rotary encoder component. And here is what you are seeing here. But this is a simple mode. You can see here the two LEDs outside of the circuit. Only this LED, you can barely see it, but it's there for the push button. But I had the circuit even with less components when I first tested. And here is what you are seeing right now, here in the video, with these two LEDs. And this is the circuit diagram. This is my Arduino board. It's called here Simulino, but make abstraction of that is actually Arduino component for Proteus simulator. This is actually a picture from a Rotary encoder. All I needed was the connections to it. I only needed to transfer what I'm having there on my breadboard to transfer it as a circuit diagram to actually know what I did there. And these are some old versions that they worked, but not completely. And this is my original reference file. My goal, as you can also see in the name here, Arduino Uno code sample. So this is the folder where I'm keeping small code sample pieces. And if we are going here in the blink button, it's very minimalistic. It's just the bare bones of what I need to know to make that project, to make it work. And the same goes for my Rotary encoder. It's the bare bones, but actually it's a bit more complicated for this component, for this Rotary encoder. But even if it's complicated a little bit more than the rest, it is working absolutely phenomenally good. So what I have here in this code is the bare minimum, is the basic code for a Rotary encoder. As I thought of it, as I feel it, it should work. Before I will get into it, let me actually present what it's doing first, and then I will come back and show more detail. So let's open a serial monitor. Let's upload. Actually, I have it uploaded already, but for this movie, done. And here I'm having this confirmation is done uploading, and also without any kind of errors or warnings. So let's see what it's doing. And also pay attention on my movement when I'm turning the knob. Pay attention here. And also pay attention in this serial monitor. So I move it slowly for you to see. You see? And now I will move it fast. So this is fast. And now in this other way. Very fast as I can. What I'm doing, let me go to 0. There is 0. Clear everything. Let me do as slow as possible. We can see here the LEDs. They will show the internal mechanism of this Rotary encoder, the contacts on it. So this is what is happening. So first red, second blue, now shutting off red and shutting off blue, and it got from one point to the other point. When I'm rotating, it's like having some points, some valleys and hills. And it's a hill, it's a valley, a hill, and another valley. It's like that. I explained this, how I'm feeling it in my hand, in my finger. And this motherfucker was down. So let me repeat it. So red, blue, off red, off blue. We are having only one number there showing this code, this binary gray code actually that you've seen in those two LEDs, or quadrature Rotary encoder is creating 4 steps as a gray code, and you've seen it with the help of those two LEDs. And my program is actually counting only one time, is decoding that binary, 4 bits of binary, one on, the second is on, then the first is off, then the second is off. This is the sequence. All this sequence of binary is decoded by my code and is correctly showed, is correctly outputted as one single number and not multiple or with errors. And as you can see, very fast I'm rotating, I'm not getting any error. And yes, I did stop and I actually checked every single number and I counted every single number to see if I'm having skipping numbers or if I'm having negative numbers between these positive numbers. When I'm rotating in that direction, if I'm having actually negative when I'm rotating in that direction, because I did have this kind of errors before in my previous codes. As you can see here, I have a list of earlier codes, and I call them all backup. And until here, so these 3, they are having some errors, and this one, it's actually this code. Before I will show you that, also show you the button press. So this is when I'm pressing the button, as long as I'm keeping it pressed, it will count from half of a second. And when I'm releasing it, it will stop. So you see? And it's extremely responsive. Very, very responsive code, what I'm having here. Very, very responsive. Those two LEDs are good when I'm very slow about it. But if I'm moving fast, they will blink, not intelligible. So this is all the functionality that I resolved with this basic program using Arduino for the Rotary encoder. and I'm very, very proud of it. I fish some code from two separate files. That's why you are seeing a lot of backup or earlier versions of this code, because I did test a ton of it. And it took me one day. So here are the errors. So Rotary Encoder working as in original code with the LCD and RGB LED. That project that I did last time, the code in it compared with this code is bad, more bad than this. This is absolutely gold. Is doing exactly what I wanted and is not having any kind of errors. I managed to make it perfect, perfect as I want it to be. In my book, in my standard, it's more than good enough. It's super good because I'm not getting any errors and I'm getting exactly what I'm asking for. So let's talk about some errors because they are important to learn about problems. And probably you've come across these problems yourself. You didn't know how to solve them, and seeing someone else solving them, it will hopefully will inspire and help you in your development with your projects. And also you will give thanks to your favorite artist electronist, Mr. Q12. So about errors, what I had. So this is the Rotary encoder is working as in the original code with the LCD and RGB LED, okay? But it's not perfect. It is confusing positive and negative rotation in random moments. So what I mean positive and negative is the sense of the, when I'm doing this is positive and this is negative. We can see it here on the serial output. So this is negative. You see, I put a minus there, and this is positive. I put a plus there. And it's counting up and down. You see 23, 22, 19, 17, and then up 18, 19, 20, 21, 22, and so on. So that's what I mean by positive and negative. I will simulate right now. This is not an error, but I will simulate the error using my knob here. So when I was counting up, I was getting this random sequential negative values, and vice versa also. When I was turning in the negative direction, something like this, I was getting in this error, some sort of skipping or misreadings. I took the original code, it was full of details for the LCD, for the RGB. I am proud of it because it worked, but I'm not proud of it how it was implemented, how it was written. It wasn't clean, and I'm not sure how clean I can make it, to be sincere. Especially in Arduino, it's a new language for me, relatively new. I didn't work in Arduino software that much. I worked for years in C# to train myself, of course, not as a job, because here in Romania you don't get a job in C#. But I love the language. I love the idea, what it was promoting. I could see what you can get with C#, and you could get a very wide range of possibilities. That's why I stayed years, like I said. I'm having like 15 years, maybe, something like that. And sometimes I was working day and night. I was non-stop coding. You know, repetition is the mother of learning, and that's what I did. So like I said, this is not even close to compare it. The time I spent coding in Arduino is not even comparable with the time I spent in C#. It's just a little bit, but I'm just familiar with language. So let's continue with the errors. Point 1, the positive is working very good with a rare button was pressed events, and also very rare, almost non-negative, like I just showed you there. So when I was turning the knob in a positive sense, I was getting a button press like that, you know, randomly. There were these two errors, confusing positive and negative rotation in a single sense when I was rotating it, like I'm doing right now. I'm turning it in one direction, but it was confusing sometimes, and it was spitting some negative there's in the same time. And this button was pressed, also was randomly like that. It was a functional code, but it was an erroneous code. And this was the second error. The negative sense of the Rotary encoder is confusing the positive and negative rotation in random moments and with rare button was pressed events, like I showed you there. It seems it prefers positive rotation over negative rotation. So because it was working a bit better in the positive sense. Because the Rotary encoder is counting 4 times, the negative error appears many more times. But I was trying to understand and to explain to myself what the hell is going on, what the error was. And all this explanation, it helped me to get to the problem, to the heart of the problem, and to actually solve it. Believe it or not. I don't believe it, I solved it, but I did, and I'm very, very proud. So this is the lesson I want to show you about this error, what I had here, because it's a very interesting error. So this is the clean code, excellent working code. This is my functional code that I just uploaded, and I will compare it with the erroneous code that I'm having. It was this convert gray to binary. This, I don't remember from where I took it. I believe I took it from a library. I actually looked inside a library, and I stumbled over this, and I put it in my code here. This is how I had it, and this is how I use it even in my original code that I use this Rotary encoder with the LCD and the RGB LED. So this is a mistake that I wasn't quite particularly aware of, and it matters how you are writing all this stuff. So pretty much, if you are reading directly the pin from inside the if statement, like I did here multiple times, so you see this digital read pin A and pin B. Again, so again, digital read pin A, and again, digital read pin A and pin B. So when I'm turning the knob, is actually checking all these pins, is checking them one by one, and if in the middle of this code, of this checking, the button is bouncing or turning, is actually performing a rotation, although the code is very fast. But if it's not fast enough and is catching in the middle, this code was the source of my erroneous output that I demonstrated here with the button and the confusing between the turns. So it matters very much what you are reading, how you are reading. So this is the correct way, and I wasn't completely very aware of it. I was aware, but I wasn't putting an accent. I wasn't embracing, putting to heart, this is the way, this is the good way how to do it, and not like this. So like this is bad because it's reading every time the pin is prone or is open to errors. So this is bad coding what I'm having here, and I wasn't very aware of it, but now I am. With this little comparison, what I'm having in both files, I can see clearly what I did wrong before and what I did right, and is working absolutely perfectly right now with this code. What is doing in this other side, I'm reading only once these two pins, but inserting them into two variables, these A and B variables, and then I'm playing only with the variables, but I'm not reading the actual pin. So even if the button is bouncing or actually turning in the middle of the checking, what is doing inside here, because this is all it's doing, is checking. If that is 0, if that is 1, it is a sequential checking what is doing here. Like in this comment is very clear. This function converts gray code into a binary / decimal number, where the binary form is 0, 0 when it's off, and it means decimal 0, 0, 1 it means 1, 1, 1 it means 2, and 1, 0 it means 3. You see 0 here, 1, 2, and 3 is returning this function of type int is returning 0 if it's checking this, returning 1, 2, or 3. So this is the difference from this code and this code. This is dealing with variables, and this is with reading directly the pin, which is wrong. Well, it's not completely wrong, but it's erroneous. So this is the little detail I wanted to show. It is the most important part of the code. So this was the biggest problem here, this function that was creating all those errors. And that's it. Let me actually show you this other folder with the Proteus file in it, with the schematic. This is the actual picture that I used here. Like I said, it is a picture that I fished from interweb. Here is the schematic. I put here a note. This is not a simulation. It's only for the circuit. Here is the complete circuit with these two LEDs, the red LED and the blue LED, and this is the white LED for the pushing button. That one. Here is the red and the blue. But here is the earlier version when it was a little bit more simpler, without the red and blue LEDs, and it's a bit more easy to visualize and to see it. So this is the negative line, what I'm having here from this middle point, you see, is going into this point, passing under that, this horizontal line is going under it and is going there, is going like that, like that. This is the negative line or the ground line, and is also here for this part as well. So this is the negative line, and this is the positive line, the 5 volts line, from that point into this bifurcation here, and from here to here, and is feeding directly this pin. When I'm pressing the button, it's putting A2 pin to high, while it's not connecting. When the button is not pressed, it is always in the low side. This here, and this one that is passing over that line, here and here, for these two LEDs. So this red and blue LED are connected to the positive with a resistor to this data line, because when I'm pressing B button, this line will become negative. So this line will become negative when I will press this B button. And when it's becoming negative, you see here is a node, here, and this LED will lit up when this line will become negative. So this is A1 linked to A1 there. This is A0 linked there and here, like that. And let me use another color here, this one, a slightly different green. Hopefully it will show a little bit. And this is to here and to here and to there. So these are the most important lines. Why I wire it like this is because I'm building this stuff. So it's very beneficial for me to have it in this a bit more complicated way of showing the schematic, but it's very beneficial for me to actually see the wiring when I'm actually wiring the circuit, because like you know me already, I'm actually soldering the wire tracks, all these wire tracks. So that's why my circuit diagram is not using this positive and this negative symbols. I could have used them very easily, especially for LEDs, here the positive, and here on this lower part, that negative, that ground symbol. But I wanted specifically to link with wires because I'm building all this circuit later. About the components, this is another important detail for all this code and all this circuit to work properly. What value of the components you are using. Of course, you have to test them a little bit. I didn't thoroughly test these two capacitors, but it works like this. It works okay. I used these two 10 nanofarads from the data line, which is A1 or A0, to the negative, which is in the middle here. This capacitor is very good to have it there, one for the bouncing and for errors, pretty much. And are these two capacitors, this orange and orange here, these two capacitors are those 10 nanofarads. And this is actually a dark green capacitor color. And that dark green is actually this 1 nanofarad And actually, I tested quite a lot of capacitors here. I was having another error here. Even if my code was doing what it's doing right now, is doing fine, but it got help from the hardware side, especially this capacitor here. You have to pay a bit more extra attention specifically to this capacitor. So this C3, important to set as 1 nanofarads for proper delay and error corrections. Check Arduino code. I copied this text from the Arduino code. Let's see. Next to the button function is this little attention. Let me actually read it from here. An important 1 nanofarad capacitor is added to the button data wire. What it means, this is data wire A2, so it's going here, you see, it's going into the A2 pin. This is the capacitor that is linked to this data wire and is then linked to the ground, as you can see here, is linked to the ground wire. If you don't add it, you will get random button press in your output. Point 1, if the capacitor, if it is small enough, will allow rotation without button was pressed event inside it. If you remember my errors, here button was pressed was because of this small capacitor. I didn't have this capacitor put here when I was getting these errors. The last component I've added to this, probably to this circuit, was this capacitor, and I had to tweak it. And I played with it. And point 2, if it's 10 nanofarads, I took another 10 nanofarads, I put it here originally, it will delay too much, makes you wait until it's ready to press again. So what it was doing when I was pressing here, there is a tiny delay right now. You see, you can hear my button, and then it's actually showing the result with a tiny little bit of delay. But this is manageable. This is good. It's a good delay. But before, let me clear it. When I was pressing it, I was waiting 1, 2, 3, and then this was showing. And then if I was pressing again or multiple times, like I'm doing right now, it was only showing only 1 time or 2 times maximum. Too big of a value here is delaying too much. Too small is like it's never there. So this data pin is not seeing that capacitor, is switching too fast. And those bouncing of the button or whatever is doing there will reappear on the line if it's way too small. So you have to play with this value. I did play already for you. You can copy directly this value and use it in your circuit diagram. It's no problem. But you still have to check specifically this capacitor here. If you are using this 1 nanofarad, you are still getting some errors from this button, then you have to play a little bit with it. Depends what components you have, how stressed they are, how new they are, etc., etc. Okay. The logic, what I want to show you here, the sense of the LEDs. So this is coming from 5 volts, like I said, is passing through this LED, which this is the positive pin of the LED, this is the negative pin of the LED, and vice versa here. This is the positive pin of the leg, that's the negative pin of the leg. This LED is surging into this data wire, pretty much. And this one is very smart here. I was playing with the LED itself, but I didn't think per se. I have an automated way of testing stuff. I'm just switching components, but I'm switching them without damaging them. If I'm not damaging anything, I am free to change whatever I please. But if I feel that I'm damaging something, then I will be extra careful, and I will think 10 times before I will mount or put. And even then I will test if it's too dangerous. But in this case, this is a very simple way of testing. I know how to work with LEDs, is not a problem. But this is a smart way of using this data line, this R2 data line, to keep it low through this LED. And as you can see here in the Proteus diagram, it is actually showing the symbol. This is the positive leg of the LED, and this is the negative leg of the LED. So pretty much when I'm pressing this C button, the positive line, which is coming from directly from 5 volts there, is getting it through the button when it's pressed, is activating this data line as positive, but also is lighting up this LED through this limiting resistor of 10 kilo. But when I'm depressing the button, when I'm turning it off, this is not negative anymore, but is not floating either. It is actually negative rail, because this is like a diode. It's actually the component here. You see the part reference is D1, it means diode 1. So a LED is actually a diode. I'm not completely sure how A0, A1, A2 are linked internally into the chip of the Arduino. I believe they have internal pull-up, is what I'm imagining it is happening. So even if this line is internally pull up to positive line, it is actually pulled down through this LED that is behaving like a diode, and through this limiting current resistor directly to the negative rail. This is how I'm turning this data line into a negative signal. This was a bit smart from my part, but I didn't actually think it like I'm explaining it right now. I was just testing stuff, and then when I completed the testings, when I actually draw it here, I realized the brilliancy, the genius of the circuit. So this is all the circuit I wanted to present. Let's go through the code a little bit and explain what the code is doing. So I am declaring here these pins are directly linked to A0, A1, A2, exactly as you are seeing here in this circuit. So A0, A1, and A2. So I'm not lying. Then I'm having this function that is converting the gray code into binary or decimal numbers, and is doing it very well this time. I'm very proud of it. the rotary read function that is making use is actually converting this numbering, what this function is outputting here. So this position variable is reading this output, whatever it is, 0, 1, 2, or 3. So this will be that 0, 1, 2, or 3, and this difference is checked here and here, and then this is checking if it's divisible by 4, because this rotary encoder is counting 4 times to make it display only one single number per 4 countings, because in one rotation is performing 4 countings. It needs to be divisible by 4. This is what this little line is doing here. I'm very glad I thought of it in my previous code. This function is used in my previous code, which is a very good function, very well thought function, but not this one as much. So I did in my previous code with the LCD and RGB project, I'm getting some errors there. I did observe there are some errors, but they are not that evident as when I'm using this clear code here. And then inside here is just outputting on the serial positive. Here is the positive and the value that is incrementing this kaka value, and that's it pretty much. And here is incrementing and here is decrementing. The kaka is incrementing and here kaka is decrementing. So the next part is this rotary, when I'm pushing the button on the rotary encoder. So this is dealing with that, and this is the actual Arduino code. All this stuff. So this is declaration, setting up the pins as inputs, activating the serial this window here with this line, and here is using those two important function, rotary read and rotary button press, this, which is this one here, the last one. And that's it. In my tests, I did stop and pay attention if it's skipping numbers, and it is not skipping numbers, and is smooth as butter, and is perfect. I could not ask for a better code. It's just exactly what I wanted is doing it. And also very, very intuitive. The way I put this positive and negative, you see in front of the numbers, is actually showing me very clearly when I'm going in one sense or the other sense. This was very smart to add. Well, I tried a lot of text here. I put this thing clockwise, counterclockwise, but I didn't like it. But this is more intuitive, it's more simple, more elegant, in my opinion. I did a very elegant job here, displaying it. The next part of this project, in the code folder, I'm having this other folder, rotary encoder for ATtiny44, but this is not actually implemented anywhere. I just prepare it, and I didn't change much. So if you remember, this was the reference board or component. It did inspire me to make this project. Basically, I'm copying it, but not like copy and paste, but interpreting it. I'm not actually copying it, but I'm interpreting it, because I don't know the code. I don't know the links, what he did here, why he is using all these resistors and those capacitors. I have no idea of his circuit diagram and the code inside this chip. And also, as I mentioned already, this chip is so pixelated in the original code, I could barely understand what the hell is going on. And again, my interpretation was that he is using this ATtiny44 chip. It was the closest I could think he used. I hope I'm right. And it's a very smart idea of using a microcontroller. And this is what I did here. I prepared this code for my ATtiny44 microcontrollers to use them, at least one of them, to actually build what I just showed you, to build this board, to make use of this ATtiny44 chip inside, exactly like this board is showing. And I'm guessing I never in my life seen this working. I'm imagining why is having this translucent knob here. I'm imagining it is having two LEDs. I believe I read its description and mentioning there that this module is having some LEDs. I have no idea what colors those LEDs are, what they are linked to. Like I linked them here, left and right, for this, or only a LED for the pressing button, or all of three, like I did in my circuit diagram. I have no idea how they implement it, but my version is using everything. My version is complete in this sense, so I'm not letting by the chance to discover that, oh hell, it's not having the button for the press, or it's having only the LED for the press button, but not having these two, which are not absolutely important, these two, red and blue, but it's a nice little detail to have, I suppose. This is what I did here. As you can see, I didn't want to leave these numbers. I only put a symbol, this right symbol and left symbol. And also for the button press, I'm sending a B for the button. And that's it. Why I'm using this minimalistic way of sending. Actually, let me run this code and upload the code. Done uploading. Here is the confirmation. And when I'm rotating, it's showing me the sense. You see? It's showing me the sense in which direction. And if I'm pressing the button, it's sending me one single character. The idea is, so this board is meant to be used with other components and with other codes. So if you are using a code in Arduino and using this board, you have to be able to read a very short signal from this board. Again, like I already mentioned, I have no idea how this board is behaving and what it's doing and how it's doing it. But I'm imagining that guy was smart enough to send very short characters, like I'm doing here, to be easy to deal with the next code that will interface with that chip.
So as you can see, in his board is having this connector and this connector. I have no idea what is doing. Probably this is an input connector and this is an output connector. So you input something here and you collect the data and read in your Arduino code from this other connector. Most probably, and it will be a serial. And also is having here on top 3.3 volts. Really? Why 3.3? I know Atitine is working with 5 volts because I did already test it. Well, whatever. Mine is better than his because it's working at 5 volts logic level, not 3.3. Now I'm seeing this little surprise. 3.3. I didn't realize this little detail. So it is a serial communication between this microcontroller and the next Arduino board or the next microcontroller or whatever you are inserting into this connector and trying to pick the data pretty much. And this is my interpretation, how I'm thinking this data should look like. Very short character. You see, is making this pattern very easy to read in the next code. That's what I did here. But again, this is only prepared to be programmed into a Tiny 44 chip through Arduino as ESP, like I showed already. And I will program that microcontroller using this modality. And after that, I will make the actual board with this Rotary encoder and with a more sturdier board, not on cardboard. It will make use of the cardboard, but I will put some reinforcement, like a piece of wood or something solid. I'm not decided yet. That's my intention, to make it a bit more strong or resilient to shock, vibration, movement. And that's the plan, that's the idea. So right now you are seeing the preparation. This project, I was actually thinking when I was doing LCD and RGB and Rotary encoder project, that was the first time when I used a Rotary encoder ever in my life. So this file, I was thinking while I was programming, while I was making that project, I was thinking to make this folder you are seeing here in this truth for Arduino Uno as a code sample, the bare minimum, the bare functionality, the basic code, and also the best code for this specific component to work very reliable and very good. And I was thinking back then to make it. And this little project, what you are seeing here already made, I was imagining back then that I really need this solved and put aside, like I'm having it right now. And right now, from this perspective, I'm very, very happy that I managed to solve all the problems and actually make a very reliable code and also a very reliable circuit that I can always come back to it, remember what the hell I did, and reuse it in the future. This was a follow-up project, but most importantly, I should have started with this project and solve all these problems and then make that project with the LCD, RGB, and Rotary encoder. That was a kind of a mistake that I jumped directly into that first and I made this second. I should have made this first and that one second. But, well, we are learning from mistakes. I'm making stupid mistakes myself. I want to say sometimes, but even if I'm doing stupid mistakes, I do learn from them. And the most important thing for everybody to understand is to catalog all your progress, to put everything in folders and to be ordered and to have them on hand, no matter how you are doing it. As you can see here, I'm having this folder into Arduino folder, and here I'm having another folder in Proteus folder, and I'm having another folder in electronic components, Rotary encoder for the components. So I'm having 3 fucking folders that I'm working with, all of them, all of 3 in different location on my hard drive. Unfortunately, I really wished I could make one single folder for everything, but life is complicated and stuff is complicated. And if you want to have a sense of order and not disorder, you have to make this risk of splitting your data into different locations. This is the management of your data, and you have to actually put aside and take time. It took me 1 day to make specifically this code, to make it work and make it work good. It took me, I stayed like probably 12 or 15 hours only on this code. I concentrated on it maximum, and I had to deal with the errors. I had to deal with the circuit. I built it up, this circuit, in the very beginning. I was actually very seriously thinking not to use this button in my very simple code, in this code sample for Arduino. I was thinking only to solve the rotary problem, and that's it, not to deal with the push button. But I'm glad that I solved all the problems. All right, so pretty much this is it about this part of this project. The next part that will come next, it will be the actual board, and yeah, it will be glorious, it will be super awesome, and you will remember me as the best artist electronist that is in this world, your favorite Q12. Okay, this is it. Thank you very much for watching, for listening, for understanding everything I have explained here, and if it is helping you in any way, do leave me a comment and tell me specifically what it did help you with, so I can track. I'm very happy to read any comments from your favorite artist electronist here, Mr. Q12. I say to you bye-bye for this part. Stay tuned for the next part, the construction part. All right, wish me luck, because I didn't do anything, it's all in plan. We will see what I will manage to make soon, very soon. Thank you, bye-bye.